Okay, in your review packet, so test is on Thursday. It'll just be over area and volume. So the topics that I covered: area, this method, washer method, and cross section. Okay. So you're responsible to know these formulas, okay? But we've been practicing through them, so hopefully you're kind of committing them to memory just because we've seen them so much. Area is just top minus bottom or right minus left with integral in front. This method is just pi r squared, either top minus bottom or right minus left. The washer method is pi big R squared minus little r squared with the radius both squared separately. And also cross-section formulas. Okay. Basically, all the cross-section formulas have base squared in them, except for rectangle. Rectangle is base times height. But the only thing different is the coefficient that lands out in front. Right. Leg on base is 1/2 base squared. Hypotenuse on the base is 1/4 base squared. Equilateral triangle over 3 over 4, and a semicircle power base. So I'll send out another reminder this afternoon about the help sessions as well as the need to memorize formulas. Okay. I'll have a help session this afternoon, tomorrow morning, and Thursday morning. Test recovery for the Chapter 5 and 6 test. Not next week, but the week after, on that Tuesday. Or if you can't make it on that day, you can come talk to me. We can figure out another day. But just like before, you have to come in and sometime before and do corrections on that test that you took. And then you can take another version up to 79. Okay, if you guys can turn to page 3. How much did we get through? A and B. Okay, all right, so let's go ahead and try part C. So you know A and B, we have to use a calculator to find those intersecting points, but then really it's just top minus bottom for both of the regions. Okay, so take a look at part C. So part C says find the volume of the solid generated when S is revolved about the horizontal line y equals -1. So I think some of you guys may have done part C already. We know that this -1, there's no chance that it could be this method, right? There's a huge gap there, so we have to do top minus bottom twice for both radius, and then it's going to end up being washer method. Okay, so for part C, here's the axis of revolution, all the way down here at -1. We extend from the dotted line all the way to the furthest boundary of our shaded region. So it's going to hit that top curve there, that sine curve. And then little radius will extend from the dotted line to the closer of the two boundaries, which is that 4 to the -x. And then we should do top minus bottom for both. Top of the big radius is sitting on the sine curve. The bottom is sitting at -1, so we just subtract them. Clean up if necessary. It just makes it a little bit easier to put into the calculator if we do a little bit of cleanup. And then top minus bottom for little radius. Top of the small radius is sitting on the 4 to the negative x. The bottom is sitting at the -1. Now that we have big R and little r, we can insert into our washer method formula. Pi from 0.178 to 1, big radius squared minus little radius squared, all into your calculator. And then just enter everything without the pi and just attach the pi at the end. Okay, all right, spend a minute to read part D, see if you can try part D, and then I'll go over it with you. Okay, so volume with different cross sections. We want to draw the base. The base is parallel to the y-axis. Which direction is that? Vertical or horizontal? Vertical, right? So y-axis is up and down, parallel to it. It will stay up and down. Create that base first. Top is sitting on the 4 to the negative x. Bottom is sitting on the sine curve. But make sure you protect that with a set of parentheses, otherwise you may forget to distribute the negative through. Okay, we'll create the area. Isosceles right triangle with leg on the base. That's 1/2 base squared. Once you have your area expression, you can now insert into your volume formula. Again, there's no pi in front because there's no rotation, right? There's no circles involved here. Units cubed. Okay, turn to page 4, read that problem, read part A. See how far I can get on your own. I'll walk through each step with you. Yes.
I think it's the same thing that you put in calculator. Oh, you screwed it.
Oh, right, yeah. So that want to enclose that entire region in that square. Okay, rotation around the line x equals -1. Okay, so just by this alone, we should be able to determine whether this is disk or washer. What do we have here? Disk, yeah. You see how that dotted line is right up against the flat surface of the shaded region. There's no gap, there's no hole. All we need is one radius. Okay. radius is perpendicular to your axis of revolution. Here we see a horizontal radius, right? So we know that there's additional setup work that we have to do. We can't just rely on this equation that they give us, right? We have to adapt it so that we can get it ready for our right minus left. All right, so what can we do to rearrange this equation so that we can solve for x? And how do I get this natural log to go away so that it's, yeah, base e? Okay, so see if you can build your radius, find your bounds, and insert into the volume formula. Okay, right endpoint of the radius is sitting on the 4 minus e to the y. The left endpoint is sitting on the x equals -1. Okay, we're stacking these circular disks from down here all the way to up here. What's the lower bound going to be? 0. And how can I find this upper bound, this upper y value? Yeah, we can just rely on this original function. Okay, it's not overly complicated. We know that this point is going to exist when x equals -1. So we can just insert -1 in for x and find the y value of that curve, right? So natural log of 5, whatever that decimal value is, that's going to be the highest y value of the shaded region. Okay, only one radius needed, so big radius squared. Okay, read part B, see if you can decide whether it's disc or washer, is it horizontal or vertical radius. Okay, try part B. This one is washer method, right? Okay, still right minus left. Bounds will be the same. Again, I want to keep reminding us that your bounds for your definite integral is just for your shaded region. Okay, don't look at your dotted line. Your axis of revolution does not play a role in determining any part of your bounds. Okay, your axis of revolution is only helpful to help you get to that radius that you need, but the shaded region is the only thing you look at for the bounds. Okay, big radius, right minus left, little radius, right minus left. Okay, any questions with part B? Okay, read part C. Part C is a cross-section problem here. No rotation. Okay, does anybody still need to look at part B? Okay. Okay, so part C says the cross-section is taken parallel to the x-axis. Which direction is that? Yeah, horizontal. So horizontal, that means you're going to create your base length, right minus left. Everything that we've done is right minus left up to this point, so you can just use a lot of the same information, right? But build the base first, and then we got to figure out how to get to the area for that rectangle. Now, they say that the height is 4. Okay, so then we have to build our rectangle, right? We know the area of a rectangle is base times height. And now we have the components to build that area. We're just going to insert them in here, right? And once you have your area representation, then you're ready to accumulate that rectangle from one end to the other end, right? So now I can insert into your volume formula. Again, there's no pi involved here. There's no circle. There's no rotation. Bounds, same in terms of y, right? From 0 to natural log of 5.
Why isn't it 0 to 4?
0 to 4. Which are you talking about? This 4 right here?
Well, it just says the height is 4.
Right, the height is 4, but the 4 is not. The 4 is sticking out of the page. The height. So we're talking about. So imagine there are all these vertical rectangles that we're building from zero all the way to natural log of 5. Yeah. So your boundary is always going to be for the shaded region. So the height is coming out of the page, so it's not. It's sitting on top of this shaded region. Okay, any questions here? Part C. Okay, let's skip over to page 7. So this is meant to be a non-calculator question. So on the test, you can use your calculator, but on some problems, I may ask you to show your work. You can use your calculator to double check everything, but to show your work. So see if you can read part A and try that. See if you can set that up. So I did top minus bottom here. I mean, you could do right minus left, but usually what we do is we typically like to explore top minus bottom first, right? It's just going to be a little bit easier, less rearranging. So if we can do something with top minus bottom, then that's the preferred method. Now, if something doesn't work out where top minus bottom doesn't fit, then we'll try right minus left. So in this case, for part A, you could do either top minus bottom or right minus left, but the easier route will be the top minus bottom. Okay, let's see if we can work this out by hand here without a calculator. Go through, set it up, get it ready for power rule. All right, we never want to insert the bounds into the expression, right? We got to do the calculus first before we can work the bounds in. Okay, any questions with A? Okay, try part B. Here, you're just writing the integral expression. We're not going to do the calculus, just the setup for the volume, and that's good enough for part B. Okay, what do you think about part B here? Disc or washer? Yeah, you see that that dotted line is not touching or is not up against that flat surface, right? It's completely off of it. There's a gap. Seven is going to be a little bit off of the shaded region. So we need two radius, right? Okay, so setup is good enough for part B. Try part C. Part C says cross-section of the solid is perpendicular to the y-axis. Which direction is that? Horizontal. Okay. So horizontal means we have to adjust our equation, right? Our equation from A and B has to be rewritten. So y equals 2 root x is talking about the curve, but it's not in the correct form. You got to get that x by itself, so divide by 2, square both sides. Now we can build the base. Right minus left. Right endpoint is sitting on the y squared over 4. Left endpoint is sitting at the 0. So right minus left, y squared over 4 minus 0 is just y squared over 4. Okay, so what shape are we building? We're building a rectangle whose height is 3 times the length of the base. So how can we build the height using what the description tells us? What would 3 times the length of the base look like? Yeah, so just take the base and multiply by 3, right? Our area of a rectangle is base times height. So insert y squared over 4 in for base, insert the 3y squared over 4 in for height, multiply those together. And once you have your area representation, you can involve the volume depth integral. What are the bounds going to be here? Lowest to highest y value on the shaded region, what do you see? 0 to 6, yeah. Okay, just asking for the setup, and that's enough. Okay, we'll continue with review tomorrow, test Thursday, help sessions today, tomorrow, and Thursday.